Hello YouTube, this is Umos03. In the previous few videos, we've been building up an understanding of while loops and for loops, and we said that basically these are mechanisms by which we can iterate through code. So we could iterate through a list and print all the elements in it. We could print a large variety of numbers, but basically we can accomplish a task that would otherwise require a repetitive number of lines of code, and then we would do that with a loop and we could iterate through. And we said we can also use these break and continue statements, and we said that break would end all operation of a loop immediately if at any point the word break was reached inside of a loop. And then continue would just end the current iteration, but it would allow the main Boolean that the loop is dependent on to be checked again for another possible iteration. Okay, more often than not, it would probably run another iteration. It would just skip the current one. So here's what we're going to do. We're going to think about list of range of x. So we've already seen something like for x in range of 6, we could go ahead and say print of x, right? And then we know that this would go ahead and print, this would print 0, 1, 2, 3, 4, and 5, right? On different lines. So then we can go ahead and run that, and then we're already familiar with that. So 0, 1, 2, 3, 4, and 5. But what happens if we say, what if we say print range of x? So it kind of seems like range of x is a list that holds the number range of, what if we say print range of 6, right? So it kind of seems like range of 6 would hold a list, will be a list that would hold the elements 0 up to 5, right? 0, 1, 2, 3, 4, 5. But then if we go ahead and run this code, it just tells us range of 0, 6. So if you want to see the actual elements that, start at 0 and go up to, everything less than 6, what you would do is you would say list of range of 6. Okay, so what I'm doing here is you can see the comment here, list of range of x is 0, 1, 2, 3, 4, 5 up to x minus 1. It's the list representation of what the for loop, what values the for loop is calling on if you say for x in range of 6. So this would just give the values, right? And this would sort of be equivalent to saying, so that's basically what you have going on there. So then that would be like, you could have also said, for t in, list, you could basically assign this to a variable. So you could have said values equals list of range of 6, right? And then you could have said for number and values, you could have said print number, right? And then you're actually just referencing each of the numbers in the array. And so they're in the list. That will go ahead and do the same thing. So that's list of range of x. And then you would also have list of range of xy. So what if you say range of 6 to 10, right? So then that would do 6, 7, 8, 9. And then you could also go ahead and say list of range of what if your first number is bigger than your second? Well, that means you'd be talking about a decrement. So this would do 10, 8, 6. And then the Boolean here is my number still greater than 4? Well, because you're talking about a negative number. So if you're incrementing as negative, then your Boolean is my current number that I'm working with still greater than 4? And then if you get to 4, the answer is no. But if you have put a 3 here, then 4 is still bigger than 3. So then you'll be able to print the 4. But the point is that this is just giving a list, right? So this is just giving a list. So you say print s of 0, that would give us the first element. So that would give us the 10, right? And then if you say s of 0 minus s of 1, you could see the difference between the first element and the second, and we would see a 2, right? Because the elements are getting 2 units smaller each time. We can also do a couple more examples with break and continue. So I wanted to give you a little example here. What if we have list equals, and then we're going to have 6, 3, the list 6, 3, and then we're going to have a 2.5, and then we're going to have a hey, and then we're going to have a true, and then we're going to have an eggs. Okay, and then what we're going to do is we're going to say t equals 0. And then while t is less than the line, well, and then what we're going to do is we're going to say while t is greater than -1. Okay, and then what we're going to do is we're going to say if t is equal to the length of the list. I'm going to call it something other than list because I guess Python doesn't really like when we call a list. So let's call it my list. And then what we're going to do is we're going to say break, but then down here, if this Boolean doesn't, happen and we don't break out of the loop, then what we could do is we could say print my list of t and then go ahead and increment t. So what this code is going to do, I just wanted to show you another example of a break, right? Because basically if you're starting at t equals 0, this, certainly the Boolean is going to be true the first time through. So 0 is greater than -1, right? And 0 is not equal to the length of my list. We haven't gotten up to 5 yet. If t is not equal to 5, the Boolean's not going to happen. But it is going to trickle up to 5, right? Because we're going to say my list of 0, and it would print this inner list. And then t is going to be taken from 0 to 1. And then you can see that this Boolean is like even more true, right? If 0 is greater than -1, then certainly +1 is greater than -1 as well. So it's not this Boolean that's going to stop our while loop. It's this Boolean that's going to stop our while loop. And that's the example of a break statement. So now if we go ahead and run this code, it would be capable of printing the elements in our list. And that's just another way of doing the same thing. We can also think about another example for a continue. So let's think about a continue. What if you said something like, let's say something like, for W in range of 30, 60, okay, for 30 and 60, okay, what we're going to do is we're going to say if X mod 3 is equal to 1 or why am I saying X? If W mod 3 is equal to 1 or W mod 3 is equal to 2, then we're going to continue, okay? And then down here, we're going to say print of W, okay? And then we also need to increment W inside of the continue logic. So let's think about what I just wrote here and what this code would do. What we're going to do, actually, we don't need to increment W by 1 because what this is going to do, so the range function, right? If you say for W in range of 30 or range of 30, 60 or range of 30, 62, right? Regardless of how many arguments you pass in, the value of W is going to update regardless, okay? So the only time you'd be talking about incrementing a value manually is usually when you're dealing with a while loop, okay? A while loop is so really primitive and bare bones, right? It only really checks a Boolean, and if the Boolean's true, it runs the code, and then checks the Boolean. If the Boolean's true, it runs the code. So you're going to have to do something that causes that Boolean to snap false. But with the range architecture, it's sort of built in. So you don't need to increment anything manually. But what you would do is you would just be looking at each of the values in range of 30 to 60, right? So W would start at 30, right? And what this code does is it says if the remainder, when you divide that value of W by 3 is 1 or 2, go ahead and continue. So that would mean that you would end the current iteration of the loop. And just as another feature of the integrated development environment, just as another aspect of PyCharm, if you go ahead and hover over this continue statement, it'll provide some context about what it does. So continue may only occur syntactically nested in a for or while loop. Okay, so when continue passes control, basically, what does it say here? It continues with the next cycle of the nearest enclosing loop. So here you would be talking about looking at the next iteration of W if the remainder is either 1 or 2. So here, if the remainder, when you divide a number by another number, is not 0, that means it's not perfectly divisible. And so W mod 3 can only be 3 things. If you divide a number by 3, you can only have 3 remainders, 0, 1, or 2. So the only way we would not continue, the only way we make it down into print of W is if W mod 3 is 0. So this is actually going to print the multiples of 3 that are at least 30 and less than 60. So now if you go ahead and run this, it would start at 30 and then you just cascade up by 3 every time, and then 57 is the last one that's printed. What if you do range of 30 to 61? Well, then you would go ahead and get that 60 there. You could have also had an else here, but this wouldn't have made a difference. So if you had said else print of W, right, continue would end the current iteration anyway. So if you're continuing, you wouldn't do this code down here anyway. So this else is optional architecture when it comes to break and continue statements. And so you can kind of play around with that and think about that on your own conceptually, why that would be the case. Is if you're ending the current iteration of the loop, then there would be no difference made as if you said else or not, because it's already going to skip it. And then one more example here. So here's what we're going to do is we're going to say t is equal to 100. While t is less than 200, what we're going to do is we're going to say print of t. And then we're going to say if t is greater than or equal to 50, what you're going to do is you're going to say t minus equals 10 and then continue. And then we're going to break. So here's what happens. This is a combined break and continue. What this is it's a Boolean, and it's going to check to see while t is less than 200. So t starts at 100, so we're going to print 100. And then this says if t is greater than or equal to 50, which 100 is, then t is going to decrease, right? And then we're going to continue. What does continue mean? It means that we don't do the rest of the current iteration. So it means that we don't break out. But then what we do is we are going to go into the next iteration of t. And now instead of dealing with t equals 100, remember we just decremented t by 10. So now it's going to run it with t equals 90, and 90 is still less than 200. And you can see that basically t is going to decrement over and over again, right? This Boolean is going to be true about 5 or 6 times. And every time t is going to go down by 10, right? And so every time it's going to print t, and it's not going to be this t less than 200 Boolean that saves us, that gets us out of the loop, because the only thing it does within the context of this loop is get smaller and smaller. So if t is greater than or equal to 50, we just decrement it, and then we don't do the rest of the loop. We just go on to the next iteration. That's okay. But then if t was not greater than or equal to 50, we skip this code and we just go down to whatever, is in the rest of the loop, and then it just says break. So then if you're talking about t equals 40, we will be printing t equals 40, but then 40 is no longer greater than or equal to 50, so 40 is the last number that we print. So now if we go ahead and run it, we get 100, 90, 80, 70, 60, 50, 40. So hopefully that's clear to you. This is an example of using a combined continue break statement, and you really should try to conceptually understand the architecture for yourself. What we're going to do is we're going to talk about functions now. So basically functions are blocks of code that achieve particular tasks. Okay, so what it's going to be helpful for us to do is break up our code into modular segments that are capable of achieving their own functionality. So right now we've been basically building all of our code in the same sandbox, but what we can do is we can add segments that will basically do computations or print statements for us. And then in our main script, in our main program, we can use those functions as additional functionality, right? That's the whole point. Functionality, that's the definition of the word, is making more operations, right? Adding more things that your program can basically do. So what we're going to do is we're going to talk about how to make a function in Python. And if you've been following along with the Java videos, remember we had 2 lessons about static methods. I think there were lessons 20 and 21. And in lesson 20, we just sort of introduced what they are. And in lesson 21, we talked a little bit more about void methods and overloaded methods. In the next 8 minutes, I'm going to try to tell you everything you need to know about functions in Python. What we're going to do is we're going to say define f, but you can call it anything you want, of x. Okay, and then what we're going to do is we're going to say print of x plus 3. What this does is we just created a function. We just created a function called x, which accepts, or called f, sorry, called f, which accepts a parameter or input x and prints 3 greater than that value, and prints x plus 3. I'm going to keep it general, so because we're going to see an example of basically how this is going to work. So prints x plus 3. Okay, so here's what we're going to do. What we're going to do is we're going to say f of 9. So what this code is going to do is it's basically going to allow us to run this function. It's going to basically make a call to this function. So it's going to go say f of 9. And then what the program is going to look to do is it's going to say, okay, f of 9, what does that mean? Okay, I need to print 9 plus 3. So this code is going to print 12. So then if we go ahead and run the main method, indeed, we get the 12 there. So this is a call to the function f with input 9. Then Python looks at f. Python is instructed to print 3 more than f's input. So it would just go ahead and print 12 because that's what the instructions were for f, right? We said for any input x, it's x plus 3, right? So for the input 102, we would expect to get 105, right? So then that's essentially what's going on with that. So that's an example of a void method. Okay, that's basically what we have going on here. It's important to realize that basically a function must be defined before it can be called or used. Okay, this is a difference between Python and Java. So what you might remember is that when we had classes in Java, what we tried doing a few times is we actually had the main method be the first method, and then we called on static methods that were defined later in the class. That's not cool in Python. So okay, so if you go ahead and move your function definition, I can just show you what would happen. We're going to go ahead and cut and paste our function down to here, and then now we have red underlines here. There's a problem. It says unresolved reference. It says, what do you mean by f? It's just going to read the code from the beginning to the bottom of the file, and it just says, I don't know what you mean by f because you haven't defined it yet. We can also think about adding and concatenating. So what if you had a multi-use function? What if you said something like, let's go ahead and bring this function back, but we're going to basically do something else here. So what if you said something like print of x plus x plus x, okay? So here what this would do is clearly that's sort of like 3 times x, right? So if you went ahead and said f of 10, then you could go ahead and run the main method and you would get 30. But what if you passed in, and then you could pass in you could pass in a different data type too. What if you pass in a float? Then you get 2.2 plus 2.2 plus 2.2. And you can see basically an example of this rounding situation here, right? Where you basically have this trailing 5. but it's in the last decimal place and it's so insignificant compared to the 6.6. So we're going to say that Python did what it was supposed to do. So that's basically f of 10 and f of 2.2. And it's underlining this, right? So it's saying expect the 2 blank lines after the class or function definition. Maybe we have too many blank lines, right? Oh, wow. So this is just another example of a Python enhancement proposal thing where sometimes it gets really picky and it's not going to throw off your program. It's not going to prevent it from running, but it's just going to give you these ugly underlines and say, hey, you might want to fix this. So anyway, you could pass in a float here. What if you try passing in a string? So what if you say t equals 25 and then t plus equals 5 and then t equals string of t, and then we'll do f of t. Let's think about what happens here. So here, a variable called t is initialized to 25, okay? And then basically 5 is added to the original value of t, so it is reassigned to 30, okay? And then basically what happens here is t is reassigned from the integer 30 to the string 30, okay? And then what happens is we apply f to the input t. So then what Python is going to do is it's going to take 30 and then apply it to f of x. So then it's going to print that string concatenated 3 times, because when we said that if you're dealing with a string plus another string is called a concatenation. It's actually going to combine the string. So we're actually not going to see 90. We're going to see 30, 30, 30. So that's the third thing that gets printed there. What if you had a multiplication? So what if you had went ahead and said x times 10? F of x, if I call f of x, I want you to print x times 10. So now if we go ahead and come down here, now what if we had said something like f of d plus o, okay? So then what would this do? Well, it concatenates d and o to get do, and then it sends that do as an input to the function f. So it's going to go ahead and print do, right? This would be an example of multiple concatenation, right? But then obviously it would work for integers too. So you could go set as say f of -1, and then it could do -1 times 10 and it would print -10. So that's kind of what's going on here. The last thing I'll do is that you can also have functions return particular values. So this is an example of a void function. So a void function usually prints something or assigns a value but does not return anything. You could also have a function that returns something. So you could say, give me the sum, okay? And what this is going to do, this is actually going to accept 2 inputs. So here's what's going to be. There's going to be 2 differences here. So 2 differences here. One, we accept 2 inputs instead of 1, which is totally valid in Python. This is going to be a function of 2 variables. So you could say print x plus y, right? And then that would require, in order for you to add 2 things together, you need to know 2 inputs, right? So addition is like a function that requires 2 inputs. But the other thing that it's going to do is it's going to return a number rather than printing anything. So what we're going to do is we're going to say return of x plus y. And so what we could do is we could say print of give me the sum of 10 and 12. So now what we do is we say that give me the sum does not itself print a number. It returns a value. It returns a value that can then be printed. So that's why we need to write print, because the function doesn't do it. The function doesn't do it. Okay, so now if you go ahead and run this code, it would be capable of running it. It would say, give me the sum of 10 and 12. This whole thing, right? This whole thing is not really a command. It's a number. It returns a number. So it says, give me the sum of 10 and 12 is a number, and it returns a number. It basically results in a value, right? And so then if you could go ahead and assign numbers. You could assign variables. So what if you said a equals give me the sum of 2 and 3? So now a would be assigned to 5, but then what if you said a times equals give me the sum of 8 and 1? So then this would be a is equal to 5 times 8 plus 1. So a is equal to basically 45, okay? And then you could say print of a, okay? And then if you want to convert it with a string, you'd have to concatenate it. So we're seeing examples where if you want to say a equals, and then the value of a, you needed to convert it to a string. So now you can go ahead and run that. And this is just an example of how a function can accept multiple inputs, okay? So a function can accept multiple inputs, and a function can either print a statement, which we call void, or it can return a value, basically, so we can assign a variable, for example, to the result of the function. So hopefully that makes sense to you, and we'll be talking about functions more, but hopefully that's a pretty thorough interview. I think it's enough for now. So from me, Mozo3, thanks for watching, and please subscribe.